In this video, I'm going to go over how to use Microsoft Excel, specifically the data analysis add-in module, to perform a single predictor regression analysis. And in this fictional study, we see we have our key outcome variable of interest, which is the score on a test. And this study is examining the potential of the amount of hours spent studying, the amount of time spent sleeping, and the amount of time spent practicing on score outcome. And these are three separate variables. And I'm just going to scroll to the bottom here, and we're going to see that we have 100 cases in this fictional study. And in Excel, this goes down to row 101 because the first row was occupied by the column headings. So that gives us a sample size of 100. So I'm going to scroll all the way back to the top, and I'm going to start by clicking Data on the menu. Go all the way to the right and hit Data Analysis, and I'm going to look for Regression. And I see Regression here, and I hit OK. Now the dialog box is looking for some the identification of the variables, and in this case the Y range, that is the outcome variable of interest, and in a correlation regression analysis we call that the criterion variable, sometimes referred to as the dependent variable. So I want to make sure I have this box with a cursor that's highlighted, and then once we have that blinking cursor, I can go back to the spreadsheet and I can click score and scroll down while I hold the left mouse button until I highlight all of the cases, and you can see that's entered here. Now it's important we click the box labels because the very first row in the data that we highlighted contains the labels. So the statistical analysis won't be conducted on the first row, but in the output will be labeled, the labels will carry forward on the output. So the X range is our predictor variable. So I'm just going to select one of the three for this single predictor ANOVA. So I'm just going to click this box here, and I'm going to scroll all the way back to the top, and I'm going to select study. I'm just going to ignore sleep and practice. So I'm going to click all the way down, scroll all the way to the bottom, capture all the data, and that's entered in here. For now, we're going to not click these other items, but if we wanted to compute the individual residual values for each score, which are the deviation values of each score from the line of best fit in the original units or in standardized residual or the standardized residuals, we would click these boxes. But for now, I'm just going to go ahead and generate the statistical analysis. I'm going to hit OK. And here we see the output for the, and I'm just going to bring the view up here. Okay, so now we can see this a little bit better, and I'm just going to widen out these columns so we can interpret these data. So what we see here at the very top, we have what's called the multiple R. This is our correlation coefficient. But the data that of interest here is the R squared value. And I'm just going to bold that right here. So this is what we want to report. So in this study, we see that there is a coefficient of determination of 0.37, which we could interpret as 37% in the variability of the outcome measure is predicted by the variability in the predictor variable. Another statistic that you'll often see is what's called the adjusted R squared value. The adjusted R squared value is a mathematical adjustment for the number of predictors, and this value will always bring the R squared value down slightly. As we have more predictors, the decrease will be a little bit more. So for our purposes, we'll just report the R squared value. The standard error is the standard error of the estimate. So if we go ahead and predict a score on the test given a hypothetical number of hours of study, that will be plus minus this amount. I'm just going to bold this here, this amount from our prediction. We see that we have 100 values in our observations. Now the two items that we want to report, I'm just going to widen this column out here as well, is the analysis of variance table and the regression table. And so the analysis of variance table evaluates whether the predictor variable is statistically significant in terms of the outcome. And so we see here we have an F value that is quite large, and that will result in a very significant, very low p-value. You can see this is 1.5899 times 10 raised to the negative 11. So this is a very small p-value for a very large f value, telling us that the model, the linear regression model here, has been found to be statistically significant. The second table that we want to present in a regression analysis is the regression table. And so here we have the two coefficients that work into the linear model of y equals mx plus b, or stated otherwise, alpha plus beta x, where the intercept refers to the y-intercept value and the study is the slope. And each of the two coefficients will have a standard error around each coefficient, and what we see here is that these values are found to be significantly different than 0 by calculating the t-statistic with very small p-values. And so the two values here for the coefficients are the two that we want to use to build our linear model, the y equals alpha plus beta x. So we substitute these two values, where the 52.15 is the y-intercept and the 1.958 is the slope of the regression line. So this ends this video on how to use Microsoft Excel to perform a single predictor regression analysis.